In this video, we'll go over LeetCode question number 15, 3-sum. Now, if you haven't already seen my video on 2-sum, I highly recommend you go watch that first because 3-sum is very similar to 2-sum, but it's a bit harder. The link is in the description, so please go ahead and watch that first. Okay, now here's the problem statement for 3-sum. Given an integer array nums, we need to return all the triplets nums I, nums j, and nums k such that I, j, and k are all different from each other, and the three values we pick must sum up to 0. The solution set also must not contain any duplicate triplets. So a brute force solution would run in O of n cubed time, so we're definitely not going to do that. However, you can see that this is similar to 2-sum, but there are a few key differences. First, we need to sum up 3 values to 0 instead of 2 values to a custom target. Second, we are returning the array values themselves, not the indices. And third and most importantly, there can now be multiple solutions and we need to return all of them, not just one. As a result of this new rule, we also cannot return any duplicate solutions. And so this is going to be the main differentiator from 2-sum. If there was only one unique solution, like in 2-sum, we could use an outer loop to fix the number at index I and then just use the same exact solution as 2-sum with a hash table. The problem with this method is that our solution for 2-sum doesn't account for multiple solutions, so we would end up returning duplicates. For example, if this is the array, then our answer would include the array -1, -1, and 2, since those three numbers add up to 0, and also -1, 0, and 1. Notice that the order in which the numbers are in doesn't matter. Now, there's another way to get 0 here, which is to use these three numbers, but we shouldn't include it in our answer because it's a duplicate of this answer. So, how will we find all solutions without including duplicates? Well, I'm going to be showing you a method that first sorts the array, then uses a two-pointer approach to solve this in O of n squared time. Now let's look at the code and solve this in Python. Let's say this is the nums array that we are given. The first thing we're going to do is sort nums, and you'll see why this is important in a second. Next, we'll create an array that will hold our final answer. Then let's start the outer loop that fixes the first number using index I. Notice that we only loop until the length of nums minus 2, or in this case, 7 minus 2, which is 5, because we always need at least 3 numbers to sum up. Now, I'm going to explain this line a little more later, but for now, I is equal to 0, so this is false, and we just move on. Here, we finally start the two-pointer approach. We're going to initialize the 2 pointers, L for left and R for right, and this is going to be our starting triplet, the numbers at index I, L, and R. We're now going to start the inner loop and keep going as long as the left pointer is less than the right pointer. The first thing we're going to do is calculate the total by adding up the numbers at the 3 pointers. So that's going to be -4 plus -2 plus 5, which is -1. Now at this point, 3 things can happen. The total could be less than 0, greater than 0, or if it's not either of those, then it must be equal to 0. Right now, -1 is less than 0, so you can see that what we're about to do is increment L. But let's take a second and think about why we're doing this. So because the array has been sorted, we know that the left pointer is pointing to the smallest number in the array to the right of I. And on the other side, we know that the right pointer is pointing to the largest number in the array. So if the total is less than 0, then we need to make the sum larger. If we move the right pointer down, then that would only make the total smaller, again, because the array is sorted. We're also keeping I fixed for now, so the only thing we can do here is move the left pointer up to make the total larger. So let's go ahead and increment L. Now we loop again and calculate the new total, which is -4 plus -1 plus 5, which is 0. That means that we found the solution, so we'll go into this else block and create an array called triplet that has our solution, which is -4, -1, and 5. We're then going to append that triplet to our answer array, and we've now successfully found our first solution. Then we're going to move the left and right pointers inwards, but we're also going to check for a few extra things. So first, we make sure that L is still less than R, and we also check if the number at L is equal to the number at index 1 of the triplet, which is the number we just added to the answer that was at index L, in this case, -1. And so if it is equal to that number, then we're going to increment L. So in other words, we want to keep incrementing L until it no longer points to -1 and it goes to a different number. And the reason we do this is to avoid adding duplicate solutions. Now we check again. We can see that L still points to -1, so if we just calculated the total again, we would end up appending the same solution. So to avoid that, we're going to increment L again. Now when we check, we see that L points to 0, so we can finally move on. Since we moved L to a different number, we know that these three numbers are definitely not going to equal 0, so we can also move R. And we'll check for the same thing, except we'll look at the number at index 2 of the triplet, which is 5. Right now, R still points to 5, so let's decrement R. Now we're finally at a different number, so we can finally calculate the new total. -4 plus 0 plus 3 equals -1, which is less than 0, so we'll move the left pointer up. But now notice that the two pointers have met in the center. That means we're done with the inner loop, and we've checked all the numbers, so we can now go back up to the outer loop, increment I, and do it all over again. Here, I is greater than 0, but the number at index I, -2, is not equal to the number at index I minus 1, which is -4. So this is still false, and we skip it. Then we'll set up our left and right pointers again, and start checking all the numbers. The total is -2 plus -1 plus 5, which is 2. This time, the total is greater than 0, so by the same logic as last time, since we need to make the total smaller, the only thing we can do is decrement the right pointer. Next, the total is -2 plus -1 plus 3, which is 0, so we found another solution. Let's create the triplet array again and append it to our answer. Then we're going to move the pointers inwards again. L gets incremented, and since it's still pointing to -1, we increment it again. Next we'll decrement R, but now both pointers have met again. So we're done with the inner loop again, and we can increment I. This condition is still false, because -1 does not equal -2, but you'll see this become useful very soon. So again, we set up L and R, and then calculate the total, which is 3. This is too large, so let's decrement R. Next, the total is 1, which is still too large, so we'll decrement R again. Now the total is -2, which is now too small, so we'll increment L. The two pointers have now met, which means that there were no solutions to be found, and we'll move on to the next I. However, now notice that this condition is true. The number at index I is -1, and so is the number at index I minus 1. When this happens, we're going to hit this continue keyword, and what continue means is to skip the rest of this iteration and continue with the next one. So we're going to skip everything below this and just increment I again. So the reason we do this is because we don't want duplicate solutions with index I at the same number. It's the same idea as the left and right pointers. We keep moving it forward until we hit a different number. Now I points to 0, so this is false and we can proceed. Let's set up L and R, and total is going to be 8, which is clearly too big, so R gets decremented. They meet in the middle, so we're done with the inner loop. But notice that that was also the last iteration for the outer loop as well. Because remember, if we moved up I to index 5, then we wouldn't have enough numbers to form a triplet. So now we're also done with the outer loop, which means the only thing left to do is to return the answer, which contains our two solutions, and we're done. Now I'm going to mention this as a bonus, but if you really wanted to optimize, then before starting each loop, you could check if the number at index I is greater than 0, and if it is, then just break out of the loop right away and return the answer. The reason this works is because since the array is sorted, we know that the number at index I is going to be the smallest out of the three numbers. So if the number at index I is already greater than 0, then there's no way that any of the other numbers, which are all larger, are going to sum up to 0. So in the case that you were given a very long array with lots of positive numbers, this piece of code right here would allow you to exit early and save some time.